Right, we've got to, in part two here, look at, we're going to convert the other direction. So we're going to find the rectangular coordinates, x and y, assuming we know the polar coordinates are theta. We can't just use what we knew from the first one. You know, x is r cosine theta, y is r sine theta. We can't just re-solve that for r or re-solve it for theta because we'd still have the r or the theta as an unknown. So we have two unknowns in one equation. So instead, what we're going to do is we're going to look at this right triangle. We're going to look at the right triangle and say, well, we know that according to Pythagorean's theorem, we know that if we take x squared and we add y, there we go, squared to it, that is equal to r squared. See, given the rectangular coordinates x, y, find r and theta. Well, here we have given x, given y, find r. We now have one equation, one unknown. So we could write this and say r is equal to the square root of y squared. So that's how we can find r given the rectangular coordinates. And if we are looking for theta, we can also use this right triangle trig and say, you know, we can see that tangent of theta is equal to y over x. And therefore, theta, if we're looking for theta, we would say theta is equal to tangent inverse of that ratio, y over x. So I guess if we wanted to isolate it, I should have put it over here. So I'll just rewrite that quick. But again, since we know y and we know x, just like we solved for r, we can solve for theta. The thing to note on the theta work here, r is pretty straightforward. You take the square root and you figure out just how big of a radius you're going to go out. With tangent inverse of this ratio, we got to be careful, and the reason is I'm even gonna put in here a note. You know what? I'll do it in blue. Tangent inverse, when you put it in a calculator, so tangent inverse, it will only give you values in certain quadrants. In fact, it's quadrant 1 and quadrant 4. My bad. But anyways, this note is kind of important because you have a point out in space that in rectangular form it ends up in quadrant 3. So you're down here in this spot. So you would go, let's see, down here. So we went some y distance, some x distance. And we know we're in quadrant 3 based on the coordinate we were given. But when I plug the tangent inverse into my calculator, it says negative 60 something. Negative 60, first of all, that would put you in quadrant 4, somewhere down here. And we know that that's not right because we know that we need to actually be in quadrant 3. So just a word of caution, what you end up having to do is go ahead and do the tangent inverse. get the number as your, what we call our reference angle, but then the last step would be to apply it to whichever quadrant you happen to be in. Now, we'll see in our first example that it does work out that we don't need to do it, but at some point you will have to do that for, in fact, I think example 2, we'll see what happens with that. But again, it's just a word of caution that you can't just assume that whatever the calculator spits out, you can just copy onto your paper. So let's get started. Example 1. Find two polar coordinate pairs. By the way, don't think I mentioned this, so let's go back for a second. This note here says rectangular point is a unique point, and that's exactly what we've been talking about in class. You know, if we have an xy 1, 3, there's no other point that I can get that would land me on that same spot on the graph. Now, if you're in polar points, polar system, there's actually infinite number of solutions, because let's say I went over some r distance and then up theta, and I wanted to find another point. If I just add 360 to my theta, if I'm in degrees, or if I add 2 pi, I could also subtract 360 or 2 pi. What we're going to find is you're going to land at the same spot. Keep the same r, add 2 pi or 360 to your theta. You'll start with one point, you'll add 360 to it, you'll come back and land on the same one. So that's why this example is saying, hey, find two polar coordinate pairs. All right, so we are being given 1, -1, so let's maybe come over here and over 1, down -1. So we're down here in quadrant 4, which is going to work out because, like I just mentioned previously, we get to use the calculator pretty much directly. So I'm going to switch back to red. But the first thing we're going to do, we're going to solve for r. And we said that r is equal to the square root of x squared, 1 squared, plus y squared, -1 squared. So r is just the square root of 2. So we've got half of our coordinate, and then we have to find theta. So we say theta, tangent inverse of -1 over 1. So when we run that, sorry, I have to keep moving my screen because it blacks part of it out. So not sure why it's doing that. Theta is equal to -45 degrees. That's what you end up with. Oop, there we go. Sorry about that. So in a way, that's kind of good. We get theta is equal to -45. That does also, depending if you want to get that into the positive, 0 to 2 pi. That is also known as 7 pi over 4. Okay, if you look at that, -45 down here, like that, could also be from the 0 mark around here, is 1 pi over 4 short of 2 pi. So what I would say is we can call this one of our coordinates. We'll call that square root 2, which is our r, comma 7 pi over 4. And if we wanted to look for a second coordinate, like I said previously, all we have to do is either add or subtract 2 pi to get that value. The other way of doing this, so if I wanted to kind of draw this out, here's pi over 4. Well, we're out here somewhere. I want to zoom in enough so that does not represent square root of 2. But the idea is we went out this direction, square root of 2 positive, and positive 7 pi over 4. Another way to look at this is to take that radius and turn that negative. If I made the radius negative, I also have to look at an angle that's out this direction. So if I went this angle out, but a negative radius, I would end up at the same point as the first one. So the question is, what is this angle? Well, that angle happens to be 180 degrees difference, or 1 pi different. So if I were to, I would subtract 1 pi from this, just so that we stay within the 0 to 2 pi. So that would end up being 3 pi over 4. There we go. So I'll try and box that in. There we go. To show you a little bit better. Those are 2 points that would get you the same spot as 1, -1 in the rectangular system. I'm going to get through example 2. It might be a little bit quicker. So I'm going to go ahead and set up a couple of things just so that I can talk through them and save a little bit of time on the video here. Here I paused the video and got set up. But the bottom line, first thing I need you guys to do, if you didn't do this in class, would be in example 2, they ask you to use the coordinate +1 and then negative square root of 3. I would like to change this to, just so it's different from the first one, I want you to change it to -1 and then the negative square root of 3, so that we can get an example where we have to change theta from what the calculator gives us. So if we do this, -1, negative square root of 3, our r value, square root of the -1 squared and the negative square root of 3 squared. So -1 is still is 1, and then square root of 3 squared is 3, so you get the square root of 4. So r is 2, we're settled with that. Theta then is taking the tangent inverse, negative square root of 3 and -1. And here's where we run into a little bit of a hiccup, and that is when you plug it into the calculator, you find that your calculator says, oh, that's 60 degrees. Well, we know that that's not 60 degrees because we plotted this and it ended up in quadrant 3. So what we have to do, this is where we got to check our work and say, well, 60 or pi over 3 is in quadrant 1, and that's not right. So what we need to do is say that reference angle is 60 degrees. So what we can do is just add either 180, if we're down here, I'm not sure what happened to all my work. Again, I don't know if you're seeing this in the recording. Or add pi. So theta actually gives, theta actually needs to be 240 degrees or 4 pi over 3. Okay, so if we look at 1 point would be radius 2 and 4 pi over 3. Another point, again, this would be if we take -2, we need to figure out, well, -2 would mean that we'd have to go backwards from some angle out here. Well, turns out that angle would be that pi over 3 that we had gotten from the calculator. But the idea is, so we go pi over 3 here, and then we shoot down through the origin negative, and we get to that point, or we go to 4 pi over 3 and then come out 2. So no matter what, both of those will get you the same point. That's all I got for this video. That is all of the examples. We are actually going to, at least for now, be ignoring this example. Third example, I just want you guys to work on some practice problems. So there you go. That's 6-2, converting polar and rectangular forms.